This is AP Calculus AB. We are on worksheet 11-5, Advanced Volumes of Revolution. These are the solutions. Again, remember that the general idea behind each of these is we need a few things. We need the start boundary, which very typically will be 0. We need the end boundary, which very typically we'll need to find boundary. I need to talk and write at different times. We need the outer function versus the inner function. And then we need to apply our new formula, which is, don't forget our pi at the very beginning. It's going to be integral with our a and b, which come from our a and b up here. And then it's always going to be our outer minus the value of k, quantity squared, minus our inner minus k, that quantity squared. And then technically dx, but whatever. All right, so in the first 3 problems, we have no calculator, but on the back 4 problems, we do have a calculator. Whenever we have no calculator, they'll want us to always do these instructions where it says, write but do not evaluate the integral expression that gives the volume when we rotate around some other line other than the x-axis. So we've seen this graph before. Now we're just rotating around the line y is equal to 7. Let's go off our checklist. Do we have a start boundary? Yes, it's 0. So we'll say 0. Do we have an end boundary? Yes, it's this x-coordinate 9. Do we have the outer versus the inner? Well, the outer function is, well, be careful here. We're rotating around the line y is equal to 7. This is the y-coordinate 6, so y is equal to 7 is above y is equal to 6, and if I'm drawing my line, it's right about there. So I'm going to say that's the line y is equal to 7. So from here, that means that my outer function is actually this function, which is represented by this function, and therefore my inner function is the top, and that is this function right here. All right, so I have everything set up. Time to apply my formula to this. This is going to be, don't forget my pi, integral between 0 and 6, and then it's going to be my outer, which is going to be 2 square root of x, it's supposed to be an x, 2 squared of x, then minus my horizontal line, 7, that entire quantity squared, minus, and then I do the next one, which is going to be 6. 6, oh, that's a good 6. 6 minus 7, that entire quantity squared, and then all of this is supposed to be multiplied by dx. Excellent, and we don't have to evaluate it. That's all we have to do. Okay, number 2. Again, what's our start boundary? 0. What's our end boundary? 4. What line are we rotating around? It's y is equal to 2, so I'm going to actually make that, and I'm saying y is equal to 2 is right about there. And again, I didn't do that quite right. It's right about there. That means my outer function is this function on the bottom, and my inner function is the one on the top. Therefore, the outer function is our linear function right here, and our inner function is this square root of x, and we have all the pieces. Let's go ahead and write our formula. So don't forget our pi. It's going to be the integral between the start, which is 0, our end, which is 4, and then I'm going to do my outer function, which is x over 2. I'm going to subtract my horizontal line 2. That entire quantity is going to be squared. Then I'm going to subtract my next function, which is going to be square root of x, and then I subtract my horizontal line 2. That entire quantity squared, and then technically all of this stuff needs to be multiplied by dx. All right, moving on to number 3. Again, what do we have here? We have our start bound, which is 0, our end bound, which is 1/2. We know that we are rotating around the line y is equal to 1, which is, that was, oh, not too bad. Y is equal to 1. And then therefore our outer function is going to be the bottom function. Our inner function is going to be the top function. And let's see what that applies to. So I believe sine of x is the inner y, because it has a slope that is immediately 1. Sine always has a slope of 1. I mean, this looks to be steeper than 1. That's because this has probably been scaled, or this is 1 and this is 1, where the x-axis and y-axis haven't been scaled the same amount. But x to the power of 3, when I take the derivative and plug in 0, you'll notice that the derivative is immediately 0, which means the slope is 0. This slope is 0, and then it goes up higher. Therefore, that's the 8x to the power of 3 function, and therefore this is the outer function. So coming over here, applying all the pieces, we have pi. Don't forget pi. It's the integral between 0 and, is it 1/2? It is 1/2. From 0 to 1/2, and then my outer function is the x cubed, right? Or 8x cubed. 8x cubed, we're going to subtract the horizontal line 1. That entire quantity is going to be squared. Then I'm going to subtract the other function. Isn't it like sine of pi of x or something? Sine of pi x. Let me double check that's the right function. Sine, yep, pi x. And that's going to be subtracting the horizontal line 1, and that entire quantity is going to be squared. And then technically all this stuff needs to be multiplied by thickness dx. Excellent. We move on to example 4 that does need a calculator. So let's go ahead and prep our calculator, make sure that we're ready. So calculator, there we go. Skinny on the left-hand side because I'm right-handed. And let's continue on. We need a start boundary and an end boundary. We don't have either of those, so I need to plug these into my y equals. I'm going to make the top one the first function that I see, which is natural log of x. That is natural log of x. Oh, I actually accidentally am typing in y2. There we go. y1 is natural log of x, and therefore y2 is going to be just x minus 2, x minus 2. And I'm going to try to graph this thing. I don't know my bounds. I'm just gonna, well, I can see that 0 is a good x minimum. For an x maximum, 5 is always too big, so I'm gonna go ahead with 5, and then I'm gonna hit zoom 0 and see what I get. Yeah, not too bad. Okay, so that intersection happens, it looks to be about pi-ish. It's 3 point something, so let's go ahead and find that. I'm gonna hit second, trace 5 to do an intersection. Okay, I forgot about that left point. It looks like about 0.2-ish, so I'm gonna say the left bound for me is 0. My right bound is gonna be, I don't know, 1 is fine. A good guess is about 0.2, and I got 0.15. Okay, so let me go ahead and annotate this graph and say, okay, we have this x-coordinate right here, and this x-coordinate right here that we're trying to find. On the first one, it's 0.159, rounding 3 decimal places, and then I'm gonna do the second one, which is gonna be second trace to do a calculation, option 5. My left bound on this one is gonna be 2. My right bound is gonna be 4. Good guess would be about 3-ish. 3.14, it's not pi, 3.146, so I'll just write down 3.146. All right, so we have our bounds. We know which function is which. This is the natural log of x function, and this is the x minus 2 function. X minus 2 is a linear function. That's what kind of gave it away. And we have all the pieces. Let's go ahead and plug this thing in, or I guess write it down. Don't forget your pi. Pi times the integral, our starting coordinate we wrote up here is going to be 0.159. Our ending coordinate is 3.146. 3.146, and then it's going to be the outer function. So, oh, where is our line? We don't even have our line. The line is going to be y is equal to -3. So -3, I can see by the graph, it's going to be somewhere like down here. I'm just going to be lazy and put it like right here, which is not perfectly accurate, but it's reminding me that I'm on the bottom. Therefore, my outer function is going to be this natural log of x, and my inner function is going to be this x minus 2. So I'm going to do my outer function first, which is that natural log of x, and then I'm going to subtract the line that I'm rotating around, which is going to be a -3. So it's minus a -3. I can write it like this, but that's how simpletons write it. You're really supposed to write it +3. Double negative makes a positive. I'm going to take that entire quantity squared minus, okay, here comes the next one. It's going to be x minus 2. So it's going to be x minus 2, and then don't forget to subtract 3. Wait. I totally made a mistake there, but I caught it. That doesn't count. Okay, I'm going to subtract. You always do a subtract in the formula, and then I'm going to subtract the -3, so I get another double negative. So a double negative is really +3, and I am, believe it or not, going to not simplify that. I'm just going to leave it like that, quantity squared, and I don't need you guys to simplify it. In fact, this makes it even more clear to me that you know what you're doing. You're adding 3. Yes, you can put a +1 if you want to try to just flex on me, but this shows that I know what bound I'm rotating around. And then don't forget your dx at the very end. I guess you don't really need the dx on this one as much as the other ones, because you actually are doing a calculation, which is way more important. Okay, so let's get out of this thing. I need to type all of that in. So how am I going to type that? I'm going to hit second to the power of to activate my pi. Math 9.159 is the lower bound. Upper bound is 3.146. Okay, functions. I'm going to start my parentheses because I'm going to square this. I'm going to say it's technically just y1, right? So I'm going to say alpha trace y1 plus 3, that end the parentheses, and that entire quantity is going to be squared. And then I'm going to subtract my next function, which I guess I could really just type. I'm going to be lazy. I'm going to do alpha trace and go to y2. I'm going to do plus 3 again, and that entire quantity squared, and I think I should be done. 34.199, let's write it down. 34.199. Excellent. All right, number 5. Okay, we don't have a start boundary. It looks like the end boundary is going to be 0, though, and I'm rotating around the line y is equal to -2. It's going to be, obviously this is not the scale, but somewhere down here I'm rotating around, which means my outer function is going to be the top function. I don't really have an inner function, so I don't have to worry about it. Therefore, I just need to find my start boundary. So I need to use, there's no way to do this without a calculator. That's a cubic. That thing's disgusting. So I'm going to go y equal, let's clear out of both of these. And we're going to type in x to the power of 3. That is divided by 4. And then I'm going to subtract x to the power of 2. And that's going to be divided by 3. And then I'm going to do minus x divided by 2, and then finally plus 3. Okay, I have the entire equation written down, and I'm going to go to my window. I do need this window to go a little bit more to the left. So I'm going to say my window goes to like -2 all the way to 0 is fine. So I'm going to just hit 0, and then I'll zoom 0 this thing. Zoom 0. So let's get rid of all of those things. Okay, so it's kind of hard to see my intersection. So hold on, let me go to my window, and I'm not seeing, did I enter the function in wrong? X to the power of 3 divided by 4 minus x squared over 3 minus x over 2 plus 3. Weird. Okay, let me change my window to -3. What's going on with my graph? Zoom 0 this thing. Okay, I can clearly see the x-intercept now. I couldn't see it as easily before. So I'm going to find that x-intercept by doing second trace, and then I'm going to do a 0 in this case because there is no intersection. So I'm going to hit option 2. My left bound is going to be -2.5, and my right bound is going to be -1.5. I can honestly just do -1. That would have been easier. It says, okay, the 0 happened at, I'm going to write this down, this spot, in pen, this spot right here is -2.161. Okay, so our bounds for this one, don't forget your pi. It's going to be pi times the integral between -2, oh, that's not where the 2 goes, -2.161 all the way to 0. And then it's that function, f of x, which I don't want to write down all over again. And then I'm rotating it around this line. So I'm going to subtract. You always start out by writing the minus sign, and then you can always change it to a plus sign in a sec. So I'm rotating around y is equal to -2, which means I now have a double negative, and now I have permission to change it to a positive to that entire quantity squared, and then I multiply all of that by dx. So I just need to type this in, and I'm ready to go. So I'm going to hit second mode to quit out of this. I'm going to do my pi first, which again is second to the power of to get my pi, math 9 to get my integral, -2.161 all the way to 0, and I can just, I've already typed in my function in my y1 spot, right? Yeah, so I can quit out of this. I can just type in alpha trace and go over to my y1, and then I can add 2, and then, I forgot I need to square all that, so I need to come back over here. I need to hit second delete in order to insert some parentheses, and then I'm going to come to the right and finish the parentheses, and then I'm going to square all of that. And if I do that and I hit enter, I get 136. That's, I think I've done something wrong. I'm looking. Oh, that is strange. I'm looking at the old answer key, and I'm getting a different answer. I'm getting 58, but I'm also finding that the intersection right here is not 2.161. Let me go back to my y equal. Did I enter something wrong? X cubed divided by 4, x cubed divided by 4, minus x squared over 3, minus x squared over 3, minus x over 2, plus 3. Oh my goodness, I have fallen into the classical trap. Wow, if you found that before me, you need to give yourself some extra credit. I thought the problem was done. I thought that was the entire function, and I was wrong. I need to read better. Like, then what is that, Mr. Sindel? What is that cosine of x? I've seen this problem so many times in students, and I fell into it. I am a victim, and I've been teaching this for a long time. So remember to read all of the math problem and then start reading the English. I needed to multiply by cosine of x there. So I need to come here and type in cosine of x. And now if I go to the graph, now I can see, yeah, that x-intercept is negative 1.373, which is the thing that I'm looking for. Again, to walk you through that, it's going to be second trace. You're going to hit 2 for the 0. My left bound, I'm going to say, is, let's clear that and say negative 2. My right bound is going to be negative 1. And you get the x-intercept of negative 1. Write this down over here. Negative 1.373. All right, so that looks closer to the answer key that I have in front of me. For some reason, I wrote 1.331. I don't know where that's coming from the answer key. Let's go ahead and assume I'm correct, and maybe the answer key is just a little bit off. Did I type in something wrong again? 3 cosine of x. That all looks good to me. Okay, if you guys are somehow getting a different x-intercept, please let me know in class, and maybe I've made yet another mistake within the same problem, which would be very embarrassing, but I'm human. It happens. All right, let's go ahead and do this whole thing again. So I can hit second enter to just re-enter everything again. And I think I should be good aside from changing my lower bound here. My lower bound, if I delete all this stuff, it's going to be 1, where did I write it down? 1.373 and hit enter, and I'm still not getting the right. Oh my goodness. Wow, I have made yet another mistake. So, and I realized that as I was hitting enter, I'm like, isn't there something missing? Yes, there is, Mr. Sindel, and here it is. I'm a bit rusty. Did you know that there was -0 here? You're like, okay, Mr. Sindel, that doesn't mean anything. Yes, it does, because this 0 here gets +2 added to it, which means that needs to be squared as well. Oh my God, you forgot about the 0, didn't you? It was pedantic before, but now it came back to haunt us with a vengeance. And then all this stuff technically needs square brackets. Okay, I'm pretty sure that's the last mistake I'm going to be making, unless I've already made one that I can't catch right now because my calculator is being really weird. I need to take this entire thing, which is correct, and I need to subtract. I guess I could subtract 4, but I'm going to be super cool about it. I'm going to write 2 squared, because that's technically what you're doing. All right. I mean, this doesn't match the answer key, but it's a lot closer. This is going to be 59.361. All right, I'd really rather not have to record that entire video. Let that be the right answer, please. And if it is wrong, I will record this one day. Maybe it's going to be 10 years from now. We'll see. Number 6. We have no picture here, which is scary, but I think we can do this. We have a region enclosed by this square root function, which has been shifted right 1. And there's some sort of vertical line x equal to 10, so that's vertical is up and down, right? So that's kind of the end boundary. I'm going to go ahead and write this as the end boundary. And the x-axis, which is, again, this hidden 0 that I need to be careful of. We need to find the volume of the solid revolved around the horizontal line y is equal to 3. Okay, so I think I understand all the pieces to this. Let's go ahead and plug everything in. So I have, you need your pi, you need the integral, and the square root function always starts at 0. It starts at 0, even though it has been shifted right 1, though, hasn't it? It doesn't start at 0 because it's been shifted right 1. And you really do need to know your general function notation. If you have anything next to the x on the inside of the parentheses or inside the square root or anything like that, that affects horizontal translation. If this was a +1, it would have been left 1. If it was a -1, it would be right 1. So if I was drawing a mini picture here before taking the integral, maybe that would help some students. Really what I have happening here is I have some sort of axis where this is maybe 1, 2, and it goes ... on and on and on. It has some function that looks like this, where this function over here goes to 10, and then I have this horizontal line right here at 10. that's kind of what I'm looking at. So I know that my integral actually starts here at 1 and not at 0, like I was originally thinking. So it's from 1 to 10 of my function, and it's going to be, again, rotated around y is equal to 3, which again is confusing because y is equal to 3 is going to be kind of inside of this diagram, I'm pretty sure. Oh no, it's going to be exactly on the edge of the diagram, I think. Will it? Well, 10, if I plug in 10 right here, 10 minus 1 is 9. The square root of 9 is 3, which means this height is exactly 3. It will be pressed right against the line of revolution, which is 3. So that's totally okay. I don't think anything weird happens even if it is on it. Only 90% sure about that. Anyway, so this is going to be the square root of x minus 1. That is the function, and then I'm going to subtract whatever this thing is, which in this case it's 3. So I'm going to come over here and subtract 3. Okay, remember in the last question when I told you, well, we have to have a 0? Where is that 0 in our picture? That 0 is right here, and if I'm drawing my picture correctly, I have a line that I'm rotating around right here. I'm rotating around that line, which means the 0 is technically my outer function, and my inner function is that square root of x function. I've done this backwards. This needs to be the inner. That needs to go second, which means I need to say, you, sir, or madame, I don't know what gender that polynomial is it's not really, is it a polynomial? It is a polynomial. Anything is a polynomial, right? 1 is a polynomial. It's a what is it? A constant monomial, right? Okay, whatever. 0 is technically squared, and then it's going to be minus 3, that entire thing squared minus this thing. Okay, now this is correct. That entire thing in square brackets dx. Whew, that was a bit to do without a picture, but I think we got it. So from here, we can actually plug this into our calculator. Ready, set, second to the power of to get our pi, math 9 to get our integral, and we're going to go from 1 all the way to 10, and then this is going to go negative, I'm just going to enter 9. 9 minus, and then, okay, start your parentheses. Here we go. This is going to be the square root of x minus 1, and then outside of the square root, I'm going to subtract 3, and then I'm going to end the parentheses, and then I'm going to square it, and I think that's everything. I'm just double checking the calculation. That looks good to me, and we get the answer, 212.057. Last year's answer key does agree with that one, so I'm feeling more confident about that one. Okay, number 7. We've got these two functions, e to the power of x and natural log of x. And these happen to be inverse functions anyway. Find the volume of the solid generated by the region enclosed by those two functions. And it tells us between a half and 1. And it's revolved around 1 is equal to 4. Okay, so this is kind of interesting that it gave us a start. This is the, I'll write this down. This is the start of our integral. This is the end of our integral. So I already know. I don't even know if I might need a picture, so I'll do an integral over here. I know the integral is going to be from a half to 1. It gave me that much. The problem is, I don't know, is this thing on the inside or the outside? Lucky for us, we have a calculator. And by the way, why didn't we use a calculator on that last one? We totally could have just grabbed that and saw what happened. Whatever, I was just being cool. So I do want to graph this thing. I'm not exactly sure what's happening. So I'm going to come up here and say, okay, clear. Let's say e to the power of x a second. Natural log e to the power of x, and come down here and say natural log of x. Okay, so I know my window, it tells me my window. It's going to be between a half and 1. So on my window, I'm going to say between 0.5 and, let's clear out of this and say 1. And then I'm going to hit zoom 0, and okay. So it's just that, it almost looks like a parallelogram almost. Which function was which? I have colors enabled. So blue is e to the x and red is natural log of x. It says the color on the left of the function. So blue is e to the x and blue happens to be on top. Okay, where are we revolving around? Okay, we're revolving around y is equal to 4, which means, okay, let me do a quick little diagram to help my mind understand what's going on here. I have axes that look like this, yoink and yoink. I have a red function that goes kind of like this, and I have a blue function that kind of goes like this. Yes, it does make that sound. And I'm revolving around the line y is equal to 4, which is way up here. I'm just going to say it's just like right up here. If I'm rotating around this axis, that means that my inner function is the blue function, and my outer function is my red function. I'm going to start with my red function, and my red function was the second one that I entered. The second one is natural log of x. So I'm going to start with natural log of x, natural log of x. I'm now going to, I don't need parentheses. I can now subtract whatever the line of revolution is, 4, and that entire quantity is going to be squared, minus the next function, e to the power of x, which is technically in blue. Might as well color code this thing. E to the power of x minus 4, that entire quantity squared. And technically all of this stuff has a pi. I'm not going to forget you. And we are all going to multiply this by dx. All right. I think we have all the pieces in place. Let's go ahead and figure this thing out with the calculator. Ready, set, second mode. Don't forget the pi. We have math 9 for our integral, and it's going to go between 0.5 and 1. Start your engines, start your parentheses rather, natural log of x, and then I'm going to end the parentheses there, and then minus 4, and then end the parentheses for the entire function, and then square it, and then subtract the next one. Start the parentheses. This is going to be second natural log to get the power of e to the power of x, then go down, I hit the right arrow key, then minus 4, I end the parentheses, and then I square that function. I think that's all the pieces correct, and I get 23.609. All right, there were some bumps along the way, but that does conclude our worksheet 11-5 for AP Calculus AB's Advanced Volumes of Revolution. Thanks for watching.